Okay, the Swiss make the best watches, but I'm German. We're the best in obeying the watch. So 10:15, let's start. Welcome to our presentation. We'll start with a round of introduction. Ladies first.
Hi everyone, my name is Maggie Hugh. I'm a specialist solution architect. I've been with Red Hat for about 3 years now, and I'm based out of Southern California. I'm from the North America Tiger team.
Hi, I'm Ishu Verma. I'm the IoT technology evangelist at Red Hat. I've been here for a year and a half, and it's been exciting times. And I'm based out of Arizona, and I'm part of the application business group.
Okay, last and least, Patrick Steiner, based in Germany. I'm a specialist SA manager for the EMEA region, and I'm also part of the IoT ambassador team that we have on a global level. Okay, to kick off our things that we're going to show you and introduce you into, let's take a little mind step in why are we talking about IoT. And for me, the talking fridge or the fridge that orders the milk at Walmart because it's empty is not IoT. That's child's play. When we talk about IoT, we talk about industrial use of IoT. And being not only a German, but someone who lives very close to the north coast of Germany, an oil rig is something that I'm familiar with. And that's what I always use as a reference for an industrial use case of IoT, is something like an oil rig, a production plant, a hospital, something where you have millions of sensors and actors and where time and flexibility and agility is crucial in the overall setup. So when we talk about the stuff that we are going to talk about in the next 45 minutes, keep that in mind. Oil rig, not refrigerator. Okay. Ishu?
Thank you, Patrick. So we're going to next couple of files talk about what are the requirements for such industrial or enterprise use case of IoT. So let's look at some of these. And obviously, it needs to have a very solid foundation, right? So this means having these systems on an oil rig that are secure and safe and minimize the risk to the equipment and personnel. It also means that because these systems are going to be remote, that you have some way of upgrading these, patching these systems as vulnerabilities are discovered automatically, right? So having automation in place. And another key consideration is that these systems are going to be there for a long time, 10 plus years, right? So you're looking at these systems and need to be upgraded in place for a long time. So our recommendation is for these systems to have the foundation built on Red Hat Enterprise Linux, and that provides a secure and trusted platform. And now keep in mind that we are not talking about things and devices, these not the microcontroller-based sensors, but we are talking about a class of devices we call intelligent gateway that buffer these end devices. So these gateways are the ones that are secure and protect your end devices.
So throughout the pitch, we will build up a demo environment, a live running demo environment that we're going to introduce you into. And, well, of course, we need something to generate data. In our case, a little sensor based on an ESP8266 microcontroller with a temperature and humidity sensor to it, which I'm just now going to power up. It's going to hopefully connect to the Summit wireless, and we'll start sending data. The gateway as a integration point where all the sensors send data to also needs to run on reliable thing, like Ishu just said. And, well, you all heard about RHEL. You all know what RHEL can do, and at some point in time, you probably decided for RHEL. And I think the exciting thing is that it runs even on small devices like this mini computer. And no, this is not a Raspberry Pi. So this is something called Middleware, runs with the Atom dual core processor, and as it is an Atom processor, this is your standard RHEL. Not a special packaging, nothing else. If you would still install via CD, you can install your multi-socket server with the same CD as this gateway. And as it runs RHEL, You can do all the management and monitoring things with this device as you do in your data center, managing it via satellite or with whatever tools you have in place. So a solid foundation for the gateway.
Another interesting characteristic when you think about IoT is the diversity of devices. Now, we are talking about devices that are legacy, that are sending messages over like different protocols, Modbus, Profibus, depending on use case, MQTT, relatively new protocol, very popular, AMQP. So there are a number of different protocols, and some are still emerging. I mean, people complain about there's no standardization in IoT, so there are still standard bodies forming and creating new protocols. So you will have these, we talked about these systems being in place for 10 plus years with these protocols still emerging. So you will need to accommodate for that. Another factor is that some of these systems are at locations where there's not a reliable network connectivity. So the messages may be lost on the way, so you need some way of making sure the messages, critical messages, get from these end devices to where the decision can be taken. So reliable data delivery. What we are suggesting is a broker like AMQ, which provides multi-protocol support. So you can have essentially like 150 plus protocols or through adapters that can be supported. And it also supports multiple message paradigms, things like basically peer-to-peer, store forward, pub-sub, so any kind of messaging paradigm will be supported. Another thing is if you want to deploy this on a cloud or premises or hybrid, you have that flexibility.
Okay, if we go back in our demo scenario and our gateway which runs RHEL, well, if it runs RHEL, you can do lots of great things with it, for example, running Docker on it. And what we did in this demo scenario is to deploy Docker on this gateway, and in one container we've got Red Hat JBoss AMQ running. And now we need to do some praises to the gods of live demos. We'll log into the management console of AMQ running on the gateway. And here you can see from our sensor incoming messages. So the sensor, as I said, reports humidity and temperature. And that's what you see here, the messages coming in. So apparently the event wireless seems to work. The sensor is sending data via wireless, via MQTT to our gateway.
Another interesting thing about IoT is the volume of data. And the scale is pretty huge. So a modern factory can generate about 1 terabyte of data a day. And a lot of this data is redundant, right? So you want this data to be aggregated, summarized, and then routed, right? So you want basically end applications or systems that are consuming this data, get it in a format that they can act on. So essentially the solution here could be Red Hat JBoss Fuse, which provides you essentially routing. So you can aggregate the data, you can transform the data, and you can get it to basically end system, databases, or applications in the form that they can consume it. And the value of enterprise, basically IoT, is to integrate this with the existing system. So whether it's your payroll system, so whether the inventory system, you want to get the data stream from IoT and get it integrated with the existing enterprise system. So you can do that as well. And just like AMQ, you can deploy it in different models, whether it's on premises, cloud, or hybrid form. You can do that with the JBoss Fuse.
So not a big surprise to you. What we did is we run Red Hat JBoss Fuse in the Camel, in the Docker container on our gateway. And it was intentionally that I replaced the box that had AMQ on it from the previous slide, because AMQ is part of JBoss Fuse. So actually I was lying on the first slide. So what Fuse is doing is more or less taking the message that it receives via MQTT, was part of the message encoded as the topic and part of the message as payload of the MQTT message, transforming it into an XML message and forwarding it via JMS to, let's say, the next level of interest. And to just verify that quickly, we will go back into the management console of Fuse running on the gateway, and we can take a look at the deployed Camel routes, and you see that here the number of messages that have been processed by this Camel route is really increasing while he's refreshing. So the messages are worked on.
Now, another key characteristic of enterprise systems is ability to take decision close to the edge where the data is being generated. And so we talked about the intelligent gateway and what purpose it serves in this whole scenario is to be able to act on this data immediately, right? So real-time decision making. You're not sending the data when the turbine temperature is rising and then waiting for the response to come back over cloud, over the network, basically latencies. So you want to be able to take action immediately. The other function is also that you want to, we talked about, there is huge streams of data being generated. So you want to make sure that you're not sending all the data. You want to aggregate it, maybe sample the data, and then send it when actually it makes a change, when it makes a difference. Another factor you want to consider is, yes, you can apply business rules, but if you hard-code it to program, then you need a programmer every time there is a business rule change to make the change. So what we recommend is having a capability like JBoss BRMS, where you can provide the intelligence at the edge by separating the business rules from the applications. So even a business analyst or business person can actually go in and express the rules in the terms that are applicable to them.
Okay. In our little setup, what we've done is we added another Docker container running on our little gateway. And the task that this BRMS instance is doing is something that we call complex event processing. So we're analyzing the stream of incoming sensor data, and we applied a really simple rule, which is this temperature or humidity that I'm receiving now different than to the one that I received in the previous message? If not, then we just neglect that data because we don't need to send or forward redundant information to a backend. So active filtering at the point of message creation. And a little verification for that. You can see here the counter running, and unfortunately the humidity sensor is not really great on that device. It sometimes freaks out. But what you can see is that the number of messages in is much higher as the number of messages out. So out of the 3,000 messages that the sensor generated since I started the environment, only 926 were forwarded to the backend. So the complex event processing really picked up and is filtering. Okay.
Okay. So I want to touch on the mobile app that we've added to this demo as well. Just some core product features that you could see. I know there are a lot of things on the screen right now, but really the core features I want to touch on in the mobile app that we developed is the MBAS services in addition to the UI that you would see in the mobile app. And then also the push notifications that we have configured using our integrated unified push server. So without going into the product features, I'm actually going to jump into the mobile application platform App Studio and just give you a really quick overview of how we would develop a mobile app using Red Hat Mobile Application Platform. So this is the Studio mobile application, Red Hat Mobile Application Platform Studio. It's web-based, so it could be SaaS-based as a hosted option. That's the original option. But now, definitely, you could have it containerized running on OpenShift as the latest version. So coming in here, I'm going to really quick go into everything. We start out with creating a new project when you start out building a mobile app. So you come out here to this project screen, and as you can see, I have many projects in here. This particular project for the IoT demo is in this one right here. So if I come in here, you will actually see 3 columns in this project. So the leftmost column is the client application. The client application is actually the UI, the face of the mobile app. In the middle tier, that's the Cloud Code app. The Cloud Code app is actually where the business logic will happen. So we have that separation between the front-end developer and the back-end developer. So front-end developer could focus more on making things pretty, using HTML, CSS, JavaScript. The client code app, the cloud code app is actually where you would use the server-side Node.js to communicate with the back-end enterprise systems. So, and then on the right-hand side, you see that column that's called MBAS services. That essentially functions the same, just like the middle tier, which is the cloud code app. But the difference is MBAS services will be reusable amongst different projects within mobile application platform. So in this example, you see the BPM cloud app in the MBAS services area. So that's actually a generic business logic layer that connects to the backend BPM, JBoss BRMS API through the RESTful API services. So I have the middle tier that's specific for this project only. So I only need in this demo, which you're going to see later, I'm actually going to list, I'm going to show a list of tasks that I need to work on from my mobile device. So that's where I could customize it for my particular project. Whereas I will actually connect to the backend MBAS services that provides all of the BPMS APIs that's available, API calls that are available, and then I will call that particular task list out of that MBAS services. So that's really the core project within, and then you will have the 3 tiers of different apps. So going into the client application, so in this case, this is the UI, the face of the mobile app. This is a simulator that you would see. So you could actually do some quick testing here in order to test some stuff that you need to do without having to download it onto your device. And really quick, the build farm is where you could actually build your mobile app once you're ready to build, and then you have your client app hooked up to your cloud app as well as your MBAS services. This is where you could come in here and do a build on that, to package that, to make it available. So if you click on the download button right here, this is a barcode that you could use from your phone using a barcode reader just to install it onto your mobile devices. And then one more quick thing is the push notification areas. This is something that we also did for this demo. The push notifications actually will go, we actually have BPM calling the RESTful API provided by the unified push server that's integrated into our Red Hat mobile application platform. And as you can see here, I actually need to configure variants. So it could be iOS, it could be Android. And based on that, there is actually a sender API that has a server URL with app ID and master secret. Those are the username and password when you send it. And in this case, you could do it in Node.js or REST API. So this is the REST API that we're using to make push notifications happen to the unified push server that's integrated here. And then push notification server, of course, will send that over the push network that, it's based on Apple or Android. So Apple will have their own Apple push network. Android will go through the Google Cloud Messaging push network. So the unified push server doesn't send the push notification directly to the devices, but it will go through that push network based on your platform, either Android or iOS. So that's really the key points I wanted to point out from our Red Hat mobile application platform for this demo.
Okay, so why were we talking about mobile BPM when we were just talking about the gateway? The demo that we want to show to you is an end-to-end scenario. So we talked about the sensor, we talked about the gateway. We also have a data center part of it. And in a nutshell, what we're trying to show is something you could call workforce management. A sensor is monitored. If a certain threshold is exceeded in a business rule, And the business rules are developed in JBoss BPM suite, where you can see here there's a very simple decision table saying if a device type temperature reports a temperature between 26 and 1,000 degrees Celsius, sorry, I'm German, then please create an error code and an error message. And this is what we're going to show now. So we have the sensor who is monitoring the temperature at the moment. We're going to increase the temperature, and we did bring some really high sophisticated technology to increase the temperature. And we will monitor the entire system and see what's going to happen. So the high sophisticated technology is going to be me breathing on the sensor, and let's see what's going to happen. Well, we did get a push notification. This means
push notification.
which means the messages were filtered. They were changed from MQTT to JMS. They were filtered. Only the rising temperature values were forwarded to the backend. In the backend, they were verified against the rules that we defined in BPM suite. And BPM suite then got kicked off a business process. And this business process that we will see in a second kicked off a push notification on the mobile. So Maggie, maybe you can show the task list, because
Yes.
someone who just gets a push notification would probably not know what to do with it.
Okay, so I have this IoT BPM test list. So what I could do is I actually could do this drop down to do a refresh on the task list. So it looks like I have one task here with the temperature, device type, device ID 122, and then data received and error message.
Okay, so now I'm going, just for fun and just to make it a bit more up to date, I'm going to introduce the fourth presenter here on stage. And please bear with me, she's a lady. She can be really, really picky and sometimes doesn't play the way that I want her to play, but let's give it a try. Alexa, ask Demo how many active events exist.
There are currently 1 open events.
Alexa, ask Demo to take the next event.
Device temperature with ID 122 reported the follow error. Temperature high.
She's getting picky. Okay, so we're not going to wait.
Do you want this event to be closed?
Yes, please. She's going to close the event, hopefully.
Sometimes she's a little slow.
She's a little bit slow. Yeah, that is probably someone.
The overwhelming Red Hat Summit.
No, I think
Wi-Fi.
someone in the AWS data center did a storage update again. Okay, but that more or less concludes the end-to-end part of the demo with the different parts.
The event has been closed.
Look at that.
So maybe you want to do a refresh just to show that the task list really got worked on.
Task list is empty.
Looks like it worked. So this concludes the demo. And as we have a little bit of time.
Thank you.
Yeah, thanks, Alexa.
Thank you, Demo God.
Questions, ideas, inputs?
How do you go about patching a embedded Linux in a portable ultrasound environment that has access to the internet?
Okay, so the question was, how would we do, and I would like to extend it from patch management to general systems management, update management on a edge component that doesn't have constant connection. So, well, the technologies that we used in this demo setup would not work for that, but we do have partner companies that we work with. For example, a company called Eurotech. And they have a technology which is called Everywhere Cloud, which does support exactly those things, to do authentication, security, and also management of edge components. Any other? Sorry? Yes, they're here. They're on Summit. I think they're also
In the IoT pavilion,
Yeah.
right next to Red Hat booth, so they're there.
All the protocols are secure. Do you, the data is also secure?
Okay, the question is security on the messages that were sent. Not in the demo, but AMQ has been around for years as a messaging technology and is used in large, very locked down situations. So yes, you can use SSL encryption and other ways to protect from an authentication, but also from a content protection of the messages, yes. Well, there is, but it's acceptable for the security that you're getting out of it.
Right. And keep in mind that, I mean, that's the purpose of the gateway, that because these end devices are going to be very not as capable for encrypting the message. So you want to protect them from, so maybe the connection from the end devices to the gateway could be unsecure, and the gateway to the back end, which is connected to internet, is secure because that's more capable system.
Do you have any documentation on how much ink flows or sensors can be supported on a particular gateway given a processor time?
No, we don't yet, because we actually don't want to do a fixed decision on which gateway technology. Our technology runs on lots of hardware, and it is up to you, up to the use case. Because some gateways or some use cases for gateways might just be message transformation and forwarding, and that will bring a totally different throughput than if you would do complex event processing and maybe also business process management on the gateway level already. All I can tell you is that this little thing here, which I said is just dual atom, and I think it has 2 gigabytes of RAM, which runs RHEL with 2 Docker containers and 2 full-blown middleware products on it, because it's not a stripped-down version of Fuse or BRMS, it's the full product. Even on here, I'm getting a throughput of 3 to 4 messages per second. And yes, this is not what I would use on an oil rig.
And I mean, the gateway, I mean, to think about in terms is, yes, it could be in a physical device like this, but it could also be if you have a, because the oil rigs will have a bunch of rack mounted servers, so you could be running in a VM on a container, right? So the gateway could be depending on a physical manifestation, or it could be actually a virtual machine, and then you can define, right, on a containerized way or not. So it depends on totally on the use case, as Patrick said.
Yes, so the presentation, the slides are going to be available. I just realized that I need to add a last slide to it, which will point you to a few Git repositories if you want to recreate that environment. It's fully available, it's full documented. You can run it on hardware, but you can also run it all Dockerized on one system. That's what I call the all-in-one demo. And I also already created a video that I'm going to release on YouTube showing the end-to-end flow as addition to the documentation.
And I believe the session is being recorded.
And I think, yeah, there's a gentleman back there with a camera.
Yeah.
Hi, Mom. So
also have
we'll
Hi,
have
Dad.
recording.
Alexa used the native API with BPM, or you developed it something?
No, I developed an Alexa skill that uses the REST APIs of JBoss BPM suite, or is calling. And that is also in my Git repo. So all documented and made available, open source. Okay, if there are no further questions, then I have the pleasure to start in time and close in time. Really German. Thanks.
Thank you. Thank you all. Want to let you guys know that we actually have more sessions coming, and I'm doing one that will go more into details with Red Hat Mobile integrating with 3Scale, our API management, as well as our JBoss BPM suite, BRMS. So it's the very last session of tomorrow. I know you're probably ready to run out for happy hour, but if you are interested, please stop by and come back and see us tomorrow, 4:30. Thank you.